A hexagonal pyramid, side of base 30 mm and axis 70 mm, rests with its base on HP and an edge of base inclined at 30 degree to VP. A section plane inclined at 45 degree to VP and perpendicular to HP passes through the pyramid at a distance of 10 mm from the axis and is in front of it. Draw the true shape of the section. So here this is a problem involving the sectioning process of a hexagonal pyramid which is resting on its base. So the very first step is draw the symbol front view and symbol top view of this pyramid using type B lines. Already I have drawn the symbol top view and symbol front view here. So we have to draw the symbol top view and symbol front view as per the directions that are given in the questions. So what are the directions that are given in the question? The solid is resting on its base on HP. So that is why in the top view you can see the base shape, which is a regular hexagon in the top view, and an edge of base is inclined at 30 degree to VP. So here in this case the edge AB and the edge BC, they are inclined at an angle of 30 degree with respect to the VP. So if you extend a straight line from this edge, so let us extend a straight line from BC. So if you measure this angle, this angle will be 30 degrees. So this angle is 30 degrees. So if we are starting the construction of this symbol top view from edge AF such that edge AF is perpendicular to the XY line, automatically the condition that is mentioned in the question, that is base edge inclined 30 degree to VP, will be automatically achieved. So we shall start it from this edge so that automatically this 30 degree condition is satisfied. After drawing the symbol front view and symbol top view of the solid, the next step is locating the section plane as per the requirement of the question. So let us assume that this ruler is indicating the vertical plane. So let us assume that this knife is representing the section plane. So if I am placing the knife like this is perpendicular to HP, and this condition also it is perpendicular to HP. So we have to make this section plane perpendicular to HP and also inclined at an angle of 45 degree to VP. So let us consider that this is approximately an angle of 45 degree with respect to VP. But exactly where it is located? It is located at a distance of 10 mm from the axis and is in front of it. So if you are observing the top view, PO is representing, this point is representing the axis. So from this point it is 10 mm in front and the section plane must be inclined at an angle of 45 degree. So let us make the inclination approximately 45, and almost when I am placing the section plane like this, it is 10 mm in front of the axis. So in this case the point PO is representing the axis. Point PO is representing the axis. This distance, this perpendicular distance is 10 mm. Now we shall locate the section plane. So in order to locate the section plane, we shall follow the forthcoming procedure. We shall take our protractor. So place this point of the protractor, the origin of the protractor, exactly on the axis. Now the base of the protractor, it is parallel to the XY line, that is these two are parallel to each other. Now we shall take an angle of 45 degrees. So we shall take an angle of 45 degrees. We shall mark a point here, and initially we shall draw a thin line at an angle of 45 degree which is passing through the axis as a preliminary step to draw the section plane. So this is not the section plane, it is only a preliminary step for drawing the section plane. So after drawing this 45-degree line along the axis, so this line and the XY line or VP, they are at an angle of 45. Our section plane is located 10 mm in front of the axis. So we shall take a distance of 10 mm in front of the line that we have already drawn. So we shall mark a point at a distance of 10 mm. Again one more point at a distance of 10 mm in front of the 45-degree line that we have already done. And connecting these 2 points, we shall draw our section plane. So section plane is drawn as a continuous thick line inside the solid, a chain line outside the solid. The ends of the section plane are thickened, and here I have marked it as horizontal trace. Why it is marked as horizontal trace? Because here we are having a section plane which is perpendicular to the horizontal plane. So definitely when the cutting process is happening, it will be touching with the horizontal plane, so that it will be having a horizontal trace. And I have marked 2 arrowheads also here. So indirectly it means that if I am viewing this solid in a direction perpendicular to the section plane, I will be getting a clear idea of the sectioned surface. So now we shall mark the various meeting points of the section plane with the various base edges and slanting edges of the solid. So here AF is a base edge. Here we are having a meeting point with the section plane and base edge. We shall mark this point as point 1. PF and the section plane is meeting here. We shall call this as point 2. PE and the section plane is meeting at this point. Let us take this as point 3. And DE and the section plane is meeting here. DE is a base edge. Let us mark this point as point 4. So we have got 4 points, 1, 2, 3, 4. Among that, 1 and 4 is along the base, 2 and 3 are along the slanting edges. We will be able to transfer 1, 2 and 4 directly to the front view, and point 3 will be transferred to the front view using a special method. Now let us transfer point 1, 2 and 4 to the front view. Point 1 is on base edge AF. AF is a point in the front view because AF is perpendicular to VP. So on this point we shall mark point 1. So this will be 1 dash. 2 is on PF. So this is P dash F dash in the front view. Now let us transfer 2 to the front view. Now let us transfer point 4, which is on DE. Four is on base edge DE. So here this is DE. This is point 4. Point 3 is on slanting edge PE, which is perpendicular to the XY line in the top view, and in the front view also PE is perpendicular to the XY line. So that is why we are not able to transfer point 3 directly to the front view. We have to adopt another method. So we shall follow this method. Initially let us draw a reference line through the axis which is parallel to the XY line. So a small thin reference line. So this line and the XY line, they are parallel to each other. Now let us rotate slanting edge PE up to this reference line using compass. Let us mark this meeting point as E1. And let us transfer E1 to the front view using this straight line which is already drawn here. Let us mark this point as E1 double dash. Now let us join E1 double dash and P dash. So this is also a thin line. So in effect what we have done is we have rotated slanting edge PE and we have made it parallel to VP, so that in the front view P dash E1 double dash will be having the true length of a slanting edge. So this slant line will be having the true length of a slanting edge. This is a concept that is originated from line inclined to both planes. Now we shall transfer point 3 up to PE1, this reference line, using compass. Let us mark this point as 3, 1. Now let us transfer 3, 1 to P dash E1 double dash. So what is the speciality of this line? It is having the true length of a slanting edge. Let us mark this point as 3 double dash. Now let us transfer 3 double dash to P dash E dash. So this is 3 dash. Now we have obtained, this point was 4 dash. We have obtained 1 dash, 2 dash, 3 dash, 4 dash. Now we shall join 1 dash, 2 dash, 3 dash, 4 dash and 4 dash, 1 dash using thick lines. So 1 dash, 2 dash, 3 dash, 4 dash and 4 dash, 1 dash, this is actually the sectioned surface. We shall hatch the inside region using hatching lines, which are thin lines and which are inclined at an angle of 45 degree with respect to the XY line. After drawing the hatching lines, the next procedure is draw the remaining portion in the top view and draw the remaining portion in the front view. So in the base, 1A is remaining. So let us draw it as a thick line. 1A. Here 1A is already there as a point, so we need not draw it. AB is remaining. So already AB is here, we need not draw it. BC is remaining. So BC is not represented here, so let us draw it as a thick line. CD is remaining. CD is represented as a point here, so we need not draw it. D4 is remaining. D4. Already D4 is represented as a dark line here. Now let us think about the slanting edges. PA is completely remaining here. PA is remaining. So we shall represent PA in the front view, but A is an invisible corner. So when you join P dash and A dash, it is an invisible line. We shall draw it as a dash thick line for the time being. PB is completely remaining. Here B is invisible. So in this case also P dash and B dash, they have to be joined as a dash thick line. PC is completely remaining. Here P dash C is invisible. Here as C is invisible, P dash C dash also will be invisible. But in this case, PD is completely remaining. So let us draw this slanting edge first. And let us draw it completely here also, which is P dash D dash. In this case, even though PC is completely remaining, we are unable to represent it as a dash thick line in the front view. The same is applicable to PA and PB also, but already I have drawn it as a dash thick line here. In this case, P3 is remaining. So here this is P dash 3 dash, we shall draw it as a thick line. Here we are having an overlap. And P2 is also remaining. Here also P dash 2 dash we are having an overlap. So here actually PA and PB, PA, PB and PC, they need not be represented here as a dash thick line. Only 3 dash B dash may be represented as a dash thick line here. So after drawing the remaining portion in the front view and top view, we have to go for the construction of the true shape of the section. In this case, as the section plane is sectioning the solid in an inclined fashion, when you are observing the solid from this direction, that is from the front view, you won't be able to get a clear idea of the section surface 1 dash, 2 dash, 3 dash, 4 dash and 4 dash, 1 dash. So we have to draw the true shape separately in this particular question. So what is the procedure for drawing the true shape? We shall reconstruct 1/4, which is our section plane, which is passing through the solid, separately to another side of the same diagram. We shall straighten this line 1/4 and we shall draw it to the right hand side. We shall measure 1/4. It is approximately 51. Whatever value you are getting, you take it as such. So this point is 4 and this point is 1. So total this distance is 51. We have taken it from the previous diagram. So the length of line 1/4 is same as that of this 1/4, which is 51. And we have drawn this 1/4 parallel to the XY line. The distance of line 1/4 with respect to the XY line, it is immaterial. You can draw it either closer to the XY line or away from the XY line. You will be getting the same results. Now we shall mark point 2 and 3 with the help of compass. So let us take 1, 2. One, 3. We shall extend projectors from 1, 2, 3, 4 to the front view. Here I have extended projectors of 1 and 4 only up to the XY line because 1 dash and 4 dash is along the base. Now we shall extend projectors from 1 dash, 2 dash, 3 dash and 4 dash to the right hand side. You need not draw projectors from 1 dash and 4 dash because already they are on the XY line. This point is 1 and this point is point 4. So this is the projector of 2 and this is the projector of 2. Likewise, three. Now we shall join 1, 2, 3, 4 using thick lines. Shall hatch the inside region using 45-degree thin lines. So by this procedure, what we have done is we have straightened this section surface 1 dash, 2 dash, 3 dash, 4 dash and 4 dash, 1 dash, and we made it parallel to VP. So that is what we have done here by straightening this section surface parallel to the XY line. So now we have got a clear idea of the section surface, or else we are getting the true dimension of the section surface 1, 2, 3, 4. Now we shall have a quick overview of the procedures. First step is drawing the symbol top view and symbol front view using type B lines. Next procedure is location of the section plane. Third procedure is marking the meeting point of the section plane with the various base edges and slanting edges of the solid as 1, 2, 3, 4. Transferring 1, 2, 3, 4 to the front view as 1 dash, 2 dash, 3 dash, 4 dash and 1 dash. Joining it using thick lines, hatching the inside region, drawing the remaining regions in the top view, drawing the remaining regions in the front view. After that, the procedure for obtaining the true shape of the section. So this is the true shape of the section, and this diagram as a whole, it is known as sectional front view, and this is a top view.